Okay, so we'll discuss today. So in the last class that we have discussed about the formation of linear programming problem, is it not? Just interact now with me. Whenever I'll ask some questions, so please reply to that question. So in the last class that we have learned about how to formulate a linear programming problem. So the few examples already I have discussed, and then I have discussed about the general mathematical description of your LPP. So in the LPP, whenever you form a linear programming problem, there will be one objective function, and there will be some constraints that is called conditions. There will be some constants, and then there will be some non-negativity restriction that already I told you that the variables whatever you choose, that all variables should be your positive, either greater than or equal to 0. These are the conditions. So obviously you understand that part. So these are the your uh, this is your objective function, and this part is your what constants. These parts are what your these parts these parts are your constant, and this is your non-negativity restriction part. That means all variables should be your either positive or equal to 0. So this was the general form that already you have discussed. Then next now already I discussed what is objective function. Objective function will you say the what is the use of objective function whenever you are forming a LPP, then what you are doing? First you are writing the objective function. So this objective function, why? What is the reason behind to write the objective function? Because if your problem is a transportation problem, then obviously the problem will be is of what type? কি টাইপের হবো? It is of the type minimization problem, is it not? যদি ট্রান্সপোর্টেশন প্রবলেম যদি থাকে, ট্রান্সপোর্টেশনের উপর যদি তোমার প্রবলেমটা যদি থাকে, then this transportation problem will be of what? Will be of what kind? It is of minimization, because you need to minimize the transportation cost. That will be our aim. So that's why if you want to write the objective function, then you won't get the result. So that is the main objective. What is your objective? Our objective is to reduce the transportation cost if it is your transportation problem. Are you getting my point? And in the same way, if your problem is of your profit problem, if you need to get profit, then the problem is of your what? Maximization problem. The problem will be what? Your maximization problem. So in that case, the objective function will be maximization of kind. So you have to maximize. So if you want to write the objective function, so you won't be able to find out at what point under the given constants, at what point or for what values of the parameters you have chosen, you are getting what? Your maximum profit. In the same way, for transportation problem, if you want to write the objective function, then you won't be able to find out for what parameter values the transportation cost will be minimum. So that's why we need to write the what? Objective function. So objective function, either it is of the type what? Maximization or minimization problem. So this is the definition. And obviously it's a linear equation. It's a linear equation. And the constant will be what? The constant will do what? The constant part is the nothing but the conditions you have imposed the condition you have imposed while forming the LPP. So in the last class that we have discussed one your example. So if you see the examples here in this example, if you see this was the problem of maximization because profit is there. So the conditions are here. The condition, first condition you have that on machine A, this is the conditions. Conditions are what? The machine A can run up to maximum of 16 hours. And on machine B, the condition is what? It run up to 20 hours. It cannot run more than 20 hours in a day. And these are the value it is given to make a chair by machine A. It requires 2 hours, and to make a table, it requires 4 hours. Machine A. Similarly, for machine B, to make a chair, it requires 6 hours, and to make a table, it requires 2 hours. So using that conditions, and this is the condition that is given, the both machine A and machine B can run more. Machine A can run up to maximum of 16 hours, and machine B can run up to 20 hours. So using this constraint, we need to maximize the profit. That means the company will manufacture how many chair and how many table so that the profit will become maximum. That was the condition. So how many chair and how many table. So your variable will be say X number of chair and X and Y number of what? Your Y number of table. The company is manufacturing X number of chair and Y number of table. And so the objective function will be what? Your Z will be is equal to 30x plus 50y. And the condition will be what? Your this 2x plus 4y should be less than is equal to 16. And this machine B, for machine B, the condition will be what? 6x plus 2y less than is equal to 20. So this is, and obviously the variable which you have chosen X and Y. So these two variable X and Y, obviously it should be positive or is equal to 0. Because X and Y are nothing but your what? Nothing but
Number of
the
chair,
number of chair and tables.
chairs and
So chair and
tables.
tables cannot be negative. Am I clear? Chair and table cannot be negative. So it must be what? Your positive, or maybe is equal to 0. So this is the condition. So these are called constraints. So using these constraints, we need to maximize the profit of the company. Are you getting my point? So this is called constants. So constant may be what? In the constant already you have seen the sign are what? Less than is equal to, or maybe equal to, or greater than equal to. These are the three signs will be there. Okay, so next part is the mathematical formulations. Already I have discussed. Huh? So just I'm showing again what is mathematical formulation. First you need to what? In a step 1, you need to decide the problem is of what kind. Whether the problem is of maximization problem or whether it is of minimization problem. Once you have decided it is a maximization or minimization, then you need to choose the variables. Like in the last problem, the company is manufacturing what? Chair and table using the machine A and machine B. So we have chosen X and Y variable as, suppose the company is manufacturing X number of chair and Y number of table. X number of chair and Y number of table. And so using that, so this is the step one. We need to specify. We need to specify the variables. That is a step one. And also we need to find out whether the problem is of maximization or minimization. That is a step one over. Now the next step, what? You need to write the objective function. You need to write what? The objective function. So obviously you have already considered the variables. Whatever the variable will be used in that problem, already you have chosen. Using that and using the means your conditions given in the problem, you need to write the what? Your objective function. Right after writing the objective function, you need to write the what? You need to write the constraints related to the what? Related to the problems. Like here, like in this problem, what? The objective function was your what? Z is equal to what? You have chosen X number of chair and Y number of table. So total profit will be what? 30 X plus what? 50 Y. And this is a problem of profit. So our objective function is of kind of what? Maximization. It is of the kind of what? It is of, this is the your what? Objective function. This is. So constants will be what? Constant will be what? 2x plus 4y, and it will be, the machine A can work or run up to how many hours? 16 hours. It cannot run more than 16 hours. So that's why it will be what? Less than or is equal to 16. So this is the first condition. Then second condition will be what? For machine B. So machine B, total time is what? Means of manufacturing what? X number of chair and Y number table is what? 6x plus 2y, and it can run up to how many hours? 20 hours. So it cannot run more than 20 hours. So that's why it will be less than or is equal to 20. And with the non-negativity restriction, that is what? Non-negative restriction is what? This x and y, this x and y should be greater than or is equal to 0. Over. Tomorrow formulation to tomorrow problem of formulation. So in this way, so whatever be the data is given in the problem, using that data, you need to formulate the LPP. Are you getting my point? Do anyone have any doubt? So let us see one problem here. So this problem, just I am explaining. Now see here, I think in the last class I have discussed that problem, no? I have discussed this problem in the last class. Okay, just if someone has any doubt, so I will explain the problem again once more. Now see, the problem is what? A factory produces two products, P1 and P2. Okay, and each product P1 requires 2 hours of molding, 3 hours of grinding, and 4 hours of polishing. So like this, the data is given in the table. So for the product P1, to manufacture the product P1, So it has to go from different process. First, the process is what it has to go for the molding. So it takes how many hours? 2 hours. For grinding, how many hours? 3 hours. And for polishing, how many hours? 4 hours. Similarly, for the product P2, it requires to manufacture one product of P2, it has to go from different process. First, it has to go for molding. So for molding, it requires 4 hours. For grinding, it requires 2 hours. And for polishing, it requires how many hours? 2 hours. So after passing through all this process, one product of P1 will be manufactured. And similarly, one product of P2 will be manufactured. Now, the next part is your, so in one product of product of P1, how much profit the company is getting? Rupees 5. How much profit company is getting? Rupees 5 in one product of P1. Similarly, for in one product of P2, the company is getting how many profits? How much? It is getting 3 rupees profit. So obviously the problem is of kind of profit. So obviously the objective function will be your maximization problem, because the problem is a profit problem. So obviously the objective function will be your what? Maximization problem. Okay. Now the conditions on all three machines, because these all are three machines. So for molding machine, it can run up to how many hours? It can run up to 20 hours. It cannot run more than 20 hours. Similarly, the grinding, it can run up to how many hours? 24 hours. And for polishing, the polishing machine can run up to 13 hours. It cannot run more than 13 hours in a day. Now the question is what? It has already been given in product P1, how much profit the company is getting, and in product P2, in one product of P2 and one product of P1, the profits are given. So for one product of P2, how much profit it is getting? Rupees 3. Am I clear? So what are the product the company is manufacturing? Product P1 and P2. So we'll consider, so at that point, the question will come in our mind that how will you maximize the profit? In order to maximize the profit, we need to manufacture the product P1 and P2 in such a way that the profit of the company will become what? Higher. That means how much quantity of product P1 and how much quantity of product P2 the company will manufacture, so that the profit of the company will be what? Maximum. So for that, what we'll consider? We'll consider that let the company manufacturing X number of product, how? X number of product what? P1, X number of product P1, and Y number of what? Product P2. And Y number of what? Product P2. Clear? So the company is manufacturing how much quantity of product P1? X, and Y number of product P2. So what will be our objective function then? For one product of P1, the company is getting 5 rupees profit, and for one product of P2, the company is getting 3 rupees profit. So what will be our objective function then? Can you tell me, anyone?
5x plus 3y.
Yeah. So that will be Z, and obviously it is what? Your maximization problem. It is of the kind of what? Maximization Z. That is equal to what? 5 x plus what? 3y. So this is objective function is over. Now the conditions. Now there are, see, the first condition will be what? For molding. It can run up to how many hours? 20 hours. And the molding machine runs 2 hours for to manufacture one product of P1. And the molding machines also runs 4 hours for what? Making one product of P2. So that is the conditions for molding will be how much it will be? That will be 2x, the total time 2x plus 4y, and it can run up to 20 hours. It cannot, capacity is 20 hours. Capacity, that means maximum capacity is given. So that means it should be less than is equal to how much? How much? It is 20. Okay. Similarly for grinding, it will be how much? It will be 3x plus how much? 2y. 3x plus 2y, and it can run up to how many hours? It can run up to 24 hours. So it is run up to 24 hours. Then the third condition will be what? For polishing, it will be what? 4x plus how much? 2y. 4x plus 2y, and that should be less than is equal to how much? 13. So this is your what? Your objective function. This is your objective function, and these are your what? These are your what? Constants. That means, or you can say conditions also. These are your constants. These are your constants. And then there is one more thing we have to add. That is what? Non-negative restriction. That is the variable x and y should be what? Your greater than is equal to what? 0, because the company cannot manufacture negative quantity. Okay. So this is the formulation of your what? So this is the formulation of this LPP of this given data. For this given data, this is the formulations. Okay. Let us see so this already I have discussed. Just you go through this. Hello. Hello. Class में बात करता हूँ. Okay, so you go through these all problems. There are many problems are given. So these are all nothing but the formulation problem. These are very simple. Okay. Just you go through these all problems. You will get understand. If you want to understand, means if you have any doubts, so what I'll do, I will share today's class videos. You can watch that one, and you can if anywhere if you are getting any difficulty, so by watching that videos you will be able to learn. So I will give you the link for that. And just you go through this all exercise also. So Once you'll be able to what to do, if once you'll be able to formulate the LPP, the other part, the solution part, using graphical method, that becomes very easy. That becomes very easy. So just to go through that one. And the solution part I will discuss in the next class. Okay. So if anyone have missed your what to say attendance, so just go to the Google Classroom and please form the fill up the forms for your attendance. Otherwise, after a few minutes, that will get disabled. So just to submit your attendance also. So anyone have any doubts? So they can ask. This is the diet problem. So now see, just I'm explaining this one. This is the cost problem actually. That is also very simple. Now see, just I'm explaining.
Sir,
Yeah.
sir, the attendance link is not activated.
No, it's active. Just to go and in the Google Classroom, in the attendance part, you'll get that one. That's active. I made active it. Now see this problem, diet problem. So see, I have only within 5 minutes I will end this problem. So now just see here. That is also very simple. Now see, a dietitian, try to concentrate. You can submit the attendance later on also. I'll give time for that. Now see, a dietitian wishes to mix two types of food in such a way that the vitamin contents of the mixture contain at least 8 units of vitamin A and 10 units of vitamin C in food. Okay, so the dietitian is going to mix two types of food to prepare the diet, and the unit of vitamin it requires is what? At least, maybe more than 8, but at least 8 units of vitamin A and 10 units of vitamin A and 10 units of vitamin. Just a minute, vitamin B is not there, vitamin C is written here. Maybe here by mistake it has been written. Okay, vitamin C. Okay, vitamin A and vitamin B. Here it has written vitamin B. So maybe it is vitamin C because B is not mentioned here in the problem. So it will be vitamin C. So just you correct it, it will be vitamin C, not B. Okay, let's see. So when the dietitian making a diet, so it is mixing two types of food to make the diet. So what is the condition in the diet? It must contains 8 units of vitamin A and 10 units of vitamin what? C. Okay. Now see the food one. There are two types of food. The food one contains, because the dietitian is what? Mixing two food, no? Two types of food. So that is your food one and food two. Now in food one, what are the ingredients there? So in food one contains 2 units per kg of vitamin A. That means in food one, per kg, how much vitamin A is there? 2 units of vitamin A is there. And 1 unit, it is 1 unit, yeah, 1 unit per kg of vitamin C. That means in food one, per kg, 2 units of vitamin A and 1 unit of vitamin C is there. Similarly, for food 2, there are 1 unit, that means per kg, 1 unit vitamin A and 2 units of vitamin C. 1 unit of vitamin A and 2 units of vitamin C per kg is there. Now, the, the cost. So what is the cost? To purchase the food one, the cost per kg is how much? Rupees 5. And to purchase the food two, the cost is how much? 7. Okay. So obviously the problem is of what? Cost problem. That means what? The problem is of what kind of? Minimization problem. That's okay. So this is the table I make. So this is vitamin A, vitamin C, food 1, food 2. This is 2. These are the things I have given. So in food 1, so how much how will consider? Let us consider the dietitian is bought x kg of food 1 and y kg of food 2. So the total cost will be what? 5x plus 7y. 5x plus 7y. So now the condition requirement is 8. That means maybe the after mixing the two foods, maybe the minimum 8 units, minimum what? 8 units of vitamin A is required. So maybe it may be more, but minimum 8 units. That means the first condition will be what? 2x plus y, 1 into y. So first condition will be 2x plus y will be what? Greater than is equal to 8. And here it will be for vitamin C, it will be x plus what? 2y. And it is minimum 10 required. Greater than is equal to what? 10. Over x greater than 0, y greater than equal to 0. That's over. That's over. So see the conditions. If you see, this is the minimization problem because cost problem. So minimization problem. This is the conditions and this is the non-negative restrictions. So easy. So if you do more problems, then only you'll be able to formulate the LPP very easily with less time. So for that you need practice. Okay. So there are many problems I have provided with this documents. Just you go through that one, you will be able to find out you'll be able to learn how to formulate the LPP. And I will share the video of this class so that in later on also you can access that